In this episode, we're going to go through the Moniker link exploit or the vulnerability, and this is a part of the Exploitation Basics module, which is a part of the Cybersecurity 101 pathway of TryHackMe, and we finished cryptography in the last episode. And so in this episode series, we're going to, or in the next 4 or 5 videos, we're going to go through all exploitation. So this is the Moniker link, which is the one that we're doing right now, that is going to help us leak user credentials using this specific CVE from 2024, which is a recent one, to bypass Outlook's protected view. Then we're going to go into Metasploit, the introduction exploitation, and then getting a reverse shell using Meterpreter, and then a final exercise, which is the blue exercise. And all of those is going, this is all focused on exploitation. So this is where it becomes, again, it's just starting to become more and more fun because we're now exploiting machines, right? And we're learning how to use exploitation tools. So in this specific episode, in this video, we're going to go through the intro for the Moniker link vulnerability and then the exploitation detection remediation of the Moniker vulnerability. And this should be really fun and it should be very exciting. And I'm super excited about it because I haven't gone through this room. So we're going to go through it together and hopefully we'll learn a lot and we'll have a lot of fun. If you'd like to support this channel, consider joining the Hackaholics Anonymous community, which is the premier YouTube community for security professionals and hackers. And we have 4 tiers: the supporter, the agent, guardian, and the master. And each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And you can join by simply clicking the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@hankhackshackers/join, and you'll be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Moniker link room. All right, so here's the story. On February 13th, I wonder if it was a Friday, 2024, Microsoft announced a Microsoft Outlook RCE credential leak and vulnerability with the assigned CVE of CVE 2024-21-413. RCE is a remote code execution exploit or vulnerability, and the name of this vulnerability has now been named Moniker Link. And Haifei Li of Checkpoint Research is credited with discovering the vulnerability, and it bypasses the Outlook's security mechanisms when handling or handing a specific type of hyperlink known as the Moniker link. An attacker can abuse this by sending an email that contains a malicious Moniker link to a victim, resulting in Outlook sending the user's NTLM credentials to the attacker once the hyperlink is clicked. So in the cryptography section, we actually talked about the various hashing algorithms, and NTLM is the hashing algorithm specific and unique to Microsoft passwords and Microsoft hash values and so on and so forth. So it sent the user's NTLM credentials, the hash values, to the attacker once the hyperlink is clicked. So this is a whole different level of phishing, right? So this comes down to literally as they clicked it, it executed whatever the code was that immediately sent that person's credentials to the attacker, which is a very, very powerful type of link if you really think about it from the perspective of like somebody who wants to go into hacking and pen testing and things like that. That is extremely powerful. So details relating to the scoring of the vulnerability are in this specific table. So the CVSS itself and all of its details, as well as the description of the individual fields here. So it was published on the 13/2024. This is the article for it. The impact has been remote code execution and credential leak. The severity is critical, obviously. The attack complexity is low, which is extremely crazy, where it's like it's a low complexity attack. I mean, the code that's attached to that link is probably not low complexity, but the attack itself, it just requires somebody to click on a link in an email. So that by itself is very, very powerful. And then it's a critical severity, and it has a 9.8 scoring, which essentially means out of 10, it has 9.8, which is it's up there. It's as high as it can probably go. It's known to affect the following Office releases. So we have Office LTSC 2021, Microsoft 365 Apps for Enterprise, Office 2019, Office 2016, and then these are the versions that are affected for each one of these releases. So this is it's very robust, it's very powerful, and I'm personally impressed. I almost like admire the person who created this thing. Learning objectives that we're going to talk about in this video is how this actually works, understanding the Outlook's protected view feature, and then using the vulnerability to leak credentials from an Outlook client. We're actually going to do that. And then the detection and mitigation measures, which again is all of this stuff is just juicy content. I'm very excited about this one. I started the virtual machine already. This is going to be the login credentials that we're going to use if we want to log into it via remote desktop. And that's pretty much it. So it says, what severity rating class has this been given? And this is a critical severity, which is a very big one. All right, great. So this actually works. This is going to be tricky because my internet keeps disconnecting. So I wonder how long my virtual machine will actually be up and if I'll be able to use it. But the answer was critical. That red window that you saw pop up at the top was because I couldn't submit my answer because I was disconnected from my internet. So that's gonna be fun. So let's move on to task number 2 itself, which is the actual vulnerability. So the Moniker link vulnerability. So one of the features about email services, so it's Outlook, Gmail, Hotmail, Yahoo, whatever. They can render emails as HTML. So you may notice this being used on your favorite newsletter. Additionally, Outlook can parse hyperlinks like HTTP and HTTPS. However, it can also open URLs specifying applications known as Moniker links. And normally, Outlook will prompt a security warning when external applications are triggered. So this is an example of one where it says Microsoft Outlook security notice. Office has identified a potential security concern. This location may be unsafe, which is the Skype name, and then call. Hyperlinks can be harmful to your computer and data. To protect your computer, click only the ones that you trust. Do you want to continue? And then you could do either yes or no. This pop-up, the one above right here, resulted of an Outlook protected view, which opens emails containing attachments, hyperlinks, and similar content in read-only mode, blocking things like macros, especially from outside an organization. So this is a really great security feature, and this specifically is not available in other email providers unless you actually configure them to do this. This seems to be something that comes predetermined or pre-configured into Outlook. So by using the file : / Moniker link in our hyperlink, we can instruct Outlook to attempt to access a file, such as a file on a network share. So this is the basic HTML code to generate a hyperlink. So a href right here, and then this piece right here that's inside of the quotes, and the whole thing should be inside of quotes technically. This piece, this entire thing right here should actually be inside quotes. So where you see this quote right here, this whole thing should be inside of quotes. And then the text that's going to read is going to be click me. Okay. So this is the place where when you do click on this hyperlink, you're going to be sent to this place. So file, attacker, IP, and then test. And the SMB protocol is used, server message block, which involves using local credentials for authentication. However, Outlook's protected view catches and blocks this attempt. So this is the link, right? So, and then in this version, we can actually see that it has the closing quotes right here. So this is the hyperlink code in HTML format. And when you see something that's click me, and then you can click on it. So for example, if we go to this thing right here, if we were to look at the code right here, it's literally an ahref type of a HTML code, and it reads Moniker links. But if I copy this link address, and then if we go to our browser here, it's not actually Moniker links. It's learn.microsoft.com, And so this link that you see right here is what's embedded inside of the quotations for that Moniker link. So what we see inside of these quotations, that's the actual link that you're going to be redirected to. But then all you see is click me, and then it's clickable, right? So the vulnerability here exists by modifying our hyperlink to include the exclamation special character and some text in our Moniker link, which results in bypassing Outlook's protected view. So for example, you would have the same thing, but now you see test right here with the exclamation, and then you have exploit, and that's basically it, which is kind of scary to think about, right? So as long as you just add for this, I mean, they've patched this, so this is it's no longer a vulnerability unless somebody is using those previous versions of Microsoft services that we just reviewed. Unless you're still using those, then you technically are fine. This thing has been patched and you no longer have to worry about it. But that's basically all it took. And imagine when they say attack complexity, that is not a complex attack that somebody's designed. It's like they just put that exclamation and then whatever the exploit itself was, and now it works and it turns it into somebody. You click me, you click on that, and then now your credentials are sent to them. That's pretty amazing. So as attackers, we can provide a Moniker link of this nature for the attack. Note, the share does not need to exist on the remote device, as an authentication attempt will be attempted regardless, leading to the victim's Windows net NTLM v2 hash being sent to the attacker. Remote code execution is possible because Moniker links uses the component object model, which is also known as COM, on Windows. However, explaining this is currently out of the scope of this room, as there is no publicly released proof of concept for achieving remote code execution via this specific CVE, because it is literally from a year ago. Probably not even a year ago, because it was February, so it's less than a year ago. February 2024 is when they caught it. So it's pretty amazing. So anyways, what Moniker link type do we use in the hyperlink? And that is the file // And let me see if I'm still connected to my internet. I'm not. So I'm gonna reconnect to my internet. This is just such a pain in the ass. And once it's reconnected, I'll press enter and then we can move on to the next one. All right, cool, that worked. And then we have, what is the special character used to bypass Outlook's protected view? And that is this little exclamation mark. And I just, oh my God, this is, it's like pulling teeth. This specific video being recorded is like pulling teeth right now. There we go, press enter, and that should now be submitted. I'm so annoyed right now. I can't, I'm smiling through it. I'm trying to smile through it and work through it, but I am flipping annoyed, let me tell you. All right, moving on, exploitation. In order for this to actually work, we will email our victim a Moniker link similar to the one that we saw in the last task. And the objective as attackers is to craft an email to the victim with a Moniker link that bypasses Outlook's protected view, where the victim's client, meaning their computer, will attempt to load a file from our attacking machine, resulting in the victim's net NTLM v2 hash being captured. So first we're going to run through a POC that we've created in this particular case, not a POS, a POC. Which is also available on GitHub, so you can access this. I don't want to click on this because I'm pretty sure I'm disconnected from the internet, so I can read through this stuff, and then when I have to do something, I'm gonna connect to the internet again. Okay, so this is a, let's see, proof of concept is what this is. So we have the author being CMnatic, and this is the GitHub link for that person. And the import of the SMTP lib library, which is basically allows you to use the SMTP protocol, the simple mail transfer protocol, to actually send out emails. And then from email mime text, we're going to import mime text. From email mime multipart, we're going to import mime multipart. And then from email utils, we're going to import format address. And this is Python, if you haven't noticed already. So if you don't know anything about Python, this might be a little bit over your head, but Python is probably the easiest language that you can learn, even if you've never seen it. So these are the imports, meaning we're going to end up using these modules from these various libraries to build out the rest of our script. Now, the first email that the first variable we're going to create is the sender's email. And in this case, it's just, you're going to hard code it. So you're going to type it in. You can also do an input prompt where you tell somebody, hey, type in your email, and then they'll type in your email. Then the receiver email is the person for your victim, right? This is their email address. The password, we're going to enter your attacker email password. So this one is not going to be hard coded into this. And this is just a good security practice. So this input command will prompt a message onto the screen when you run this script where it says enter your attacker email password. So you enter your password. And then the HTML content variable is basically this. So this is the HTML content that you want your link to point to, right? And so it's an HTML page, very simple. And then the only thing that is available here is this click me link. So this is not even an HTML page. It's just HTML content that specifically is an href piece of code that points to that link that has that exclamation exploit portion. And this is it. And it's going to read click me. and then the person will have the option to click on it or not. And then you use the messages. This is specifically from our email library that we're used. So we're going to use the my multi-part, and then we're going to create a subject from to, and then the subject is going to be the CVE itself. The from is going to be the sender's email. The to is going to be the receiver's email. And then the message HTML is going to be MIME text HTML content, which is this thing that we saw right here. And then we're going to make sure that it's in HTML format. And then message attach the HTML, which is this, which is going to be the content that we saw, which is right there. And then the server is going to be smtp lib.smtp, and then the mail server. So you could do, smtp.gmail.com, for example. The default port for SMTP is port 25. And then we're going to essentially try to log in, except if you can't log in, it'll print it out, and then try the server send mail, except if it can't, it'll just tell you what the error is. Very simple script, right? So not a complicated script as far as Python is concerned anyway. This is on the simpler side of the Python script. So what this proof of concept does is that it takes the attacker and victim's email. Normally, you would need to use your own SMTP server. This has already been provided for us in this room. It requires the password to authenticate. For this room, the password for this the attacker is this, and then that's the attacker, what we saw. The email content is the HTML content variable, which contains our Moniker link as an HTML hyperlink. And then we fill in the subject to, from, details, Finally, it sends the email to the mail server. So let's use Responder, which is a command line tool, to create the SMB listener on the attacking machine. For the THM attack box, the interface will be IENS5, and the interface name will differ if you're using your own device. For example, if you're using Kali, you would have to run ifconfig, or if you're using Microsoft as your attack box, you're going to run ipconfig, so on and so forth. For the intensive purposes, I hope you're using Kali on your end, because it'll be pretty identical to everything that we're going to do on our end, and you don't have to customize your syntax. So the interface name for you is going to be different anyway, because when you run your ifconfig and you look at your main interface that's attached to your IP address, it might be ENS0, whatever. So if you would like some homework, an impact server can also be used. And so this is what the responder is going to look like. And this is what we're going to be running on our attack box. This part is going to be a nightmare because my internet keeps disconnecting. So just trying to connect to the attack box is going to be a nightmare. But anyways, so we would run the responder-i on the interface ENS5, and it'll run, and it's listening for any events that are happening. And then we open the vulnerable machine by actually opening this specific vulnerable machine that we've already launched in our exercise here. And then when we open it, this is essentially what it's going to look like. It's going to be a Microsoft Outlook from what it seems like. And then I don't want to sign in or create an account is what we're going to click. X on top of the pop-up to get rid of the product key. And then when completed, you'll see the Outlook interface for this room. The victim's mailbox has already been set up in Outlook for you. And that's what it's going to look like. And so we're going to return to the attack box, and we'll copy and paste the proof of concept, the code that we saw, into the attack box. And basically what he's doing is that he's copying it and pasting it into the Nano text editor. And I mean, for the most part, I don't think they even changed anything. I feel like they literally copy pasted exactly the full thing as the code, and they didn't even modify let me see if they modified their username or email or anything. No, he didn't modify the email or anything like that. It seems like those are the actual emails that we're going to be using in our proof of concept. So we'll need to do some initial setup on the attack box before running the Python. Modify the Moniker link on line 12 to reflect the IP address of the attack box. Okay, so I guess they will do that. Replace the mail server placeholder on 31 with the IP address that I have here. And now we can run the exploit when prompted for the attacker's email password. Enter attacker as the password. And the Python script will print email delivered when the email has been sent. If the script complains about the authentication failure, ensure that you've correctly replaced the values in the exploit Python file. Now let's return to the vulnerable machine and check for the new email, which is going to be this thing right here. And then there's the click me button, and then we click on that. And so click on the click me hyperlink and then go to the responder, and then we'll see that we have actually captured the NTLM v2 credentials of this person. So that's pretty gnarly. That's pretty crazy to think about. So what is the name of the application that we use on the attack box to capture the hash? And that is responder. So I need to connect to the freaking Wi-Fi again, and I'll be able to answer it. And it said, what type of hash is captured once the hyperlink in has been clicked? And I think that's pretty much it. So let me first see if I can actually even answer these questions. Okay, so we didn't even have to run the exercise to be able to get these answers. The name of the application that we use on the attack box to capture the user's hash is responder, and the type of hash that we're capturing is the net NTLM v2. So those are the answers essentially that we need for this particular task to be finished. But because I can't connect to my internet, it keeps disconnecting, and I apologize for that. I feel like I'm like doing bad customer service or something right now. So in order to kind of help you understand this, if you're running this on your side, is when you use this script right here, this Python script, there are a few things in it that you do have to modify. Okay, so the few things that you have to modify in this particular case are going to be the mail server value. So let's say if you use TryHackMe, they give you a mail server for this exercise, and it said that the mail server itself was the IP address that they gave us, because that's the one that we set up for this room for the most part. So where is it? This IP address. So on line 31, we have to replace the mail server value with this, which is the IP address that has been assigned to me as my mail server. So this will change every time you load this room and you set up, you click on the virtual machine start machine button. When you click on that, this IP address will change. For you, if you're doing this on your own machine, you can use literally smtp.gmail.com, and what you're going to have to do is you're going to have to create a password, an application password, in order to be able to use the SMTP server for Gmail. And I have basic instructions for how you can actually do that. So I'm going to show you the instructions for that, so you know how to generate your app password, and then you can go ahead and use the Gmail server, assuming you have Gmail. I don't know how to do it for Yahoo, but for the most part, if you ask Gemini or GPT or something and you say, I want to use the SMTP server for Yahoo or something like that, what is the default port, and so on and so forth, what do I have to do? So for the most part, for all of them, it should be similar steps. I'm going to show you what is specific to Gmail, and then we'll go ahead and fix the rest of it. And the moniker link. So there are only two things in the script that you have to modify. The moniker link, which is on line 12, to reflect the IP address of the attack box. So this is your attacking machine. In this particular case, it will be your actual computer. Okay. And then when you replace the mail server placeholder on line 31, that would be the SMTP link that you would provide. So literally smtp.gmail.com would be in replacement of this. And then right here where it shows you 25 as the port, I think it's 527. I think like the default SMTP server port for Gmail is 527. I'm going to verify that for you right now. But for that's pretty much the only thing you would have to modify is this portion to read smtp.gmail.com, and then this is going to be the port, which I think is 527. I'm not sure, but we'll verify that right now. And then on line 17, where he said enter, what did it say on line 17? It said to put the IP address of your attack box. So on line 12, modify the moniker link in the thing to reflect the IP address of your attack box. So your moniker link on line 12, which is going to be towards the top of this whole thing. So technically this would be, I think, line 1, because these comments should also count as individual lines as well. But if we go to our moniker link, which is this thing right here. So this moniker link is on line 12. So this portion would be your IP address on your computer that you're going to use, because you're going to end up running responder from your computer's command line. And if you're doing this with the attack box, you would replace it to be the IP address of the attack box that's been issued to you on TryHackMe, and then you would change the IP address of the mail server to whatever the IP address is that they've assigned to you on TryHackMe. If you're doing this on your own computer, so if you're not going to use TryHackMe's attack box or TryHackMe's virtual server or virtual machine, then you would need to change the mail server to smtp.gmail.com and then change the port to the port that I'm going to share with you right now. And then this is going to be the IP address of your machine, okay? That's pretty much it. Those are the only things that you have to modify for this script in order for the script to work. You also actually, my bad. So you do have to change the email addresses here as well. So it would not be attacker@Moniker link. It would actually be, you know, for me, hackhackshackers@gmail or something like that, right? And then I usually just send it to the same Gmail account. So I'll start it from one Gmail account and I'll send it to the same Gmail account. So that'll be the sender and the receiver email. And then the password is going to be the application password if you're going to use smtp.gmail.com. If you're going to use the attack box right here, the password was attacker for this. So where it says input password, where you get prompted to input the password, it says just type in attacker, and that'll be the password for the attacker's Gmail, which is here. So these things, if you're going to use the attack box, you don't need to change. If you're going to use your own machine, then you do need to change this to your email. You need to change this to your email. And then the password is going to be the application password from Gmail. And I'm going to show you how to get that right now. All right, so these are the instructions that I created for one of the scripts that I created for Hackaholics Anonymous. And this was, you know, it was the disk usage monitor. So what it did was it would just monitor the disk of the computer, and then when certain data shows up, you would get notified, and it will send you an email using the smtplib library on Python. Okay, so just to kind of tell you, this is what this part means specifically, but everything else will apply to you if you're going to use your own computer and you want to use the SMTP server from Gmail to be able to send this for you. Okay, so essentially you would need to go to myaccount.google.com/security. And then when you go here, it's basically just going to take you to the kind of like the settings of your Google account. And then there's going to be a search box at the very top. Now, in order for this to actually work, you need to make sure that you have multi-factor authentication turned on for the Gmail account that you're going to be using to do this. If you don't have multi-factor authentication turned on, you're not going to see the option for app passwords, okay? That part is, I just want to make sure you understand that. So if you have MFA turned on, then you go to the search box at the top and you type in app password. And then it's going to give you a bunch of like options. Like in the drop down, you'll get a bunch of options. And then there's an article that literally says apps and passwords and things like that. And you click on that and it gives you the direct link to go create a new application password. When you click on that link, you actually have to re-enter your Google account's password to just log back in and verify yourself again, because app passwords are not the most secure way to do it. You can use, you know, sign in as Google instead of using an app password and creating your own. So this is, you'll get that kind of a notification, and then it says, you know, are you sure you want to do this? Make sure you log in, and then you log in. When you log in, then you basically says, you know, enter the name of the app that you want to create a password for. And you can do, you know, Moniker link exploit, whatever. And that would be the name of it. And then you press enter, and then you'll see it pop up on the screen with the new app password. This will be the only time that you'll be able to see this password, because once you close this pop-up, you're not going to be able to open it back up. Okay, so just keep that in mind. Once the pop-up shows up and you see the password, you're going to get a 16-character password in groups of 4, and each group is separated by a space. When you want to enter it into the script that we just saw as your password, you have to remove the spaces so that you just have one block of 16 characters. This is very important. So you'll have 4 space 4 space 4 space 4. So there's 3 spaces basically. I don't know how many times I just counted. So 4 space 4 space 4, and that's basically it. 4 space 4 space 4 space 4. Yeah, so 4 groups of 4. That's, the math should be fine. This is not hard arithmetic. And so when you have these 4 groups of 4, you just have to remove the spaces between those 4 groups of 4 so that it just turns into one long block of 16 characters, and that's your password, okay? And then you save that into a separate file, because apart from that one time that you actually see it on the pop-up, you're not going to be able to open it back up again. And then if you wanted to see it again, you would have to go through this whole process and create another app password. So that's basically it. That's how you would do this. And then once you have that app password, then when you run that script and it says enter your password, you can just paste the app password and then everything else will work exactly as so. The next thing that I'm going to do is I'm going to verify for you what the default SMTP port is for Gmail. Okay, so these are the default ports. It's either 465 or 587 depending on the connection. And in the script that we just looked at, there was no mention of the type of connection that's actually being created. So there's no mention of SSL or TLS or anything like that with the server being connected. So for the SMTP lib server that's being created, there's no mention of it. So you can try either the 465 or the 587 to see which one will actually work, because I think the default would actually be SSL and it would not be TLS. So since that's the case, you can do the 465 instead of 25 right here. This would be smtp.gmail.com. And then up here, you would have your email addresses. The same email address is what I would recommend you use. And then this would be your IP address on your machine. And then from that, you would be able to run it. And the password, you already saw how we can generate an application password for Gmail using the Google security support link. So apart from that, that's pretty much it. That's the only thing that you need to do to modify this so that it can actually run. And then as long as you have Responder installed on your machine, then your interface for whatever your main interface would be, that would be the interface that you have this IP address next to. So when you have the interface, you need to just make sure whatever interface you chose, that's the IP address that you're going to put over here so that it'll actually work. Otherwise, this connection back to the responder won't work for you. So that's like the best that I could give you, honestly, as far as the instructions for this are concerned. I apologize. My internet is not the best today, and it keeps dropping my connection, and it's extremely annoying, and I am sincerely apologetic. Like, I feel embarrassed that this isn't working, but at the very least, we also got the answers, and then I gave you like a really detailed breakdown of actually how to modify that script to make it work for you. If you're using the TryHackMe, oh, this is a free room. Oh my God, you should definitely use TryHackMe because it would save you all the headache of using the SMTP Gmail server. My God, I should have just looked at this at the beginning. My bad, dude. Seriously. Hopefully you stuck it with me throughout this whole portion. So this is a free room. You can actually get a free registration with TryHackMe and use this room, and then you'll be able to launch the attack box as well as the victim machine, and then you'll be able to use the Outlook email and all of that stuff without having to do any of the extra stuff that I talked about in the Gmail SMTP. You have extra information in case you wanted to do it on your own machine, but you don't need to because you could literally use a free subscription to TryHackMe and then go ahead and do this. So anyways, now that we've gotten that out of the way, let's talk about detection. For detection, Yara rules are really amazing and very useful. This is something that was created by Florian Roth, which is kind of like the founding father of Yara and Yara rules. And he's actually created this specific rule that we're looking at here that can detect emails containing the file element in the Moniker link. And so if we go ahead and all they're doing is they're displaying the contents of the Yara rule on our screen. And this is the rule itself. This is the metadata of it. So description, author, reference, date, da 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 da. None of this stuff has anything to do with the functionality of the Yara rule. The functionality of the Yara rule comes with strings right here and everything else that's going on. So these are individual variables. So the A1, A2, and then XR1. And then this looks like a massive freaking regular expression that is detecting all of these things. So all of these potential extensions or formattings of file, which is it's long. It's like a very, very, very massive regular expression that will just detect to see if this file // this whole thing right here, if it exists inside any email. And then file size less than 1 kilobytes, and all of A and 1 of XR. So all of these two, so subject and received, and then one of these things, meaning one of docx, txt, pdf, xlr, like one of these things has to just be present in that attachment. And as long as that's there, then this rule is going to be triggered. Wireshark also has something. The SMB request from the victim to the client can be seen in a packet capture with a truncated net NTLM v2 hash. So this is the packet that we're looking at in particular. No, I'm sorry. This is the one. So we're looking at 290 right here. That's the one that we're looking at, I believe. So let's look at if we can actually see the packet number that we're looking at. I can't see the packet number right now because it's not available in the details of it. But let's see, security blob. Oh, right here. So it is this one. So it says THM Moniker link TryHackMe. I believe that's the packet that we're looking at in this particular case. Now it says, security blob is truncated, and then the rest of it has been blocked out because that's probably what we need to use to answer the questions here. NTLM secure service provider, the NTLM response has been blocked out. The NTLM v2 response has been blocked out, and all of those things are truncated. Username is TryHackMe, hostname is THM Moniker link, so on and so forth. So this is the packet, if you capture it inside of Wireshark, that you can see what the details of this are to potentially detect what's going on. Wireshark isn't going to send you an alert, right? Wireshark is for people who know how to investigate things, and you can see packet by packet. So you can see all of the data of the traffic and what's going on. It's just that you need to know what you're looking for. So if you're looking for something truncated, or if you're looking for something that has to do with the NTLM value, because you know what this specific CVE is going to do, is it's going to try to send out your NTLM credentials, right? So if you know that's what you're looking for, you can search for that and then do your investigation. So that's basically it. So this is what detection can help you do. If you are faced with creating some kind of detection rules, you should just use the Yara rule by Florian Roth for the Moniker link CVE, which is also, this is the ID for it. So CVE 2024-21413. And then it's all over this video, so you should have no problem finding this Yara rule that's been created by Florian Roth. You can also, this is the part where you would have to, specifically, you would have to be able to manually type all of this out. So it's just better to go ahead and copy and paste this into a Yara file. And this room is free, so you can just get access to this and copy and paste it into your own computer and use it. There's a bunch of different things that you can do to actually copy this Yara rule for yourself. It's listed on GitHub as the CVE 2024-21413, or CV, if you do Yara rule Microsoft Outlook remote code execution 2024, you'll be able to find the GitHub link as well. So all of this, these are all different ways that you can get access to this specific Yara file, which is, I would say, the best way to detect this specific vulnerability, because if you're going to rely on Wireshark, that means you have to rely on your own abilities as an investigator to be able to find the packet that has to do with that Moniker link. And that's pretty much it. So now we can move on. Of course, I'm disconnected from the internet. So now we can move on to remediation. For this specific vulnerability, Microsoft has already included patches to resolve it in February's Patch Tuesday release. You can see a list of the KB articles by Office Build by Googling it, because I'm not going to click on that link because it's not going to work because of my internet. Updating Office through Windows updates or Microsoft Update Catalog is strongly recommended because it just comes pre-configured, and everything that needs to be patched will be patched if you just go through Windows Update or the Microsoft Update Catalog. So highly recommended to go through Microsoft to actually update your system. Additionally, in the meantime, it is a timely reminder to practice general safe cybersecurity practices. For example, do not click random links, especially from unsolicited emails. If it's coming from a email that or like from a person that I have not subscribed to, or from a person that I don't recognize, I automatically report it as a phishing email or a spam email. I stopped actually reporting them as spam because usually spam automatically gets filtered and it goes into my spam mailbox. But if it actually makes it to my inbox, I automatically report it as phishing if I don't recognize, because I know who I subscribe to. I know which services I subscribe to. I know which celebrities or what can I say, influencers, like these thought leaders in tech or in the business world I've subscribed to. So I know all of the services that I've subscribed to. If I don't recognize the service, I will immediately unsubscribe, because sometimes they do sell your email address to each other so that they can expand their list and whatever. I'll immediately unsubscribe. And if I definitely think that it's a phishing email, then I'll go ahead and immediately report it as phishing. I never click on links from anything that comes in. This is just a really, really, really big thing to understand. Do not click on links if you don't recognize the email, because it's not about, oh, I'm going to click on the link and I'll go and check out the website and see what happens. Never. Because now you know that if you just click on the link can be modified to capture your credentials, and that's it. At that point, you're screwed. So never click on the freaking link. If you want to look at the HTML, the source code of the email, and then see what the link is, and then go to VirusTotal and check the link to see if it's a malicious link, sure, you could do that, but I would highly, highly, highly recommend to not actually click on it. I have said it a dozen times. Do not say you were never warned, okay? You have been warned. Do not click on random links. You should already know this by now. Preview the links before clicking on them. You could actually do that. You could right-click on a link, and then you can preview it. So, for example, right-click on this, and then you can say, I'm going to copy the link address, and I can go to VirusTotal and then paste the link address, and then from there I'll see what the link itself is, because it's not going to open in my computer. It's just going to open up in VirusTotal, and VirusTotal is going to tell me whether or not it's malicious. And if it's not malicious, if VirusTotal actually, because if VirusTotal checks like 90 something vendors that have all of their individual databases, so if it doesn't show up as malicious in VirusTotal, I have like a 90 something % confidence that it's not malicious. But if I don't recognize them, I just don't click on them anyway. And then forward suspicious emails to the respective department responsible for cybersecurity. So this could be within your company. It could be the FBI's phishing links or the virus links on the FBI database. It could be for Apple. It could be for Microsoft. All of these major companies house massive lists of suspicious email links and suspicious email addresses and IP addresses and so on and so forth. And they all communicate with each other. So the FBI list, for example, is referenced by Microsoft and Google and all of those people, obviously. And for the most part, Microsoft also will leak their entire list of suspicious emails or IP addresses to share them with each other, because it's open source data. Like, it doesn't, they're not going to leak the, oh, this is the vulnerability that they hacked. They're going to be like, this is the IP address that hacked us. So put this on all of your intrusion detection systems and SIM software and security appliances and firewalls, and block this IP address and block this email address. They will definitely release that information. It's really good practices to actually do that. So all of this stuff should be forwarded if you actually suspect it. When you report it as phishing inside of Gmail, it automatically gets reported because you're forwarding it and reporting it as phishing. So they automatically flag everything about that email, and then they send it to their respective database. Since the vulnerability bypasses Outlook's protective view, there is no way to reconfigure Outlook to prevent this attack. Additionally, preventing the SMB protocol entirely may do more harm than good, especially as it is essential for accessing network shares. However, you may be able to block this at the firewall level depending on your organization. The best practice is don't click on the damn link. That's basically all I can say. So you have been warned like a dozen times by now, okay? So I did my part. Now it's up to you to be diligent. So that's basically it for this one. And then we're going to check the conclusion. I'll give you a couple of final notes, and we are done with this video. Okay, so the conclusion is basically telling us congratulations. It was fun. Maybe it was fun for you. And I'm going to try to delete all of in the edit, I'm going to get rid of all of those extra pieces that were annoying as hell. So you're going to see this final polished video. And not all of the tooth pulling portions, the hair. If I had hair, I would pull my hair out. It was fun for the most part. I mean, it was nice to learn about this, and it was nice to learn the Python script that's available, the Yara rule that's available, all those things that we could actually leverage to protect ourselves in this particular situation. And it's as recent as 2024, and it's against a massive company like Microsoft. And it was so simple. That's the thing that's like the scariest part, where it's like, imagine what a hacker is doing, and they're sitting there and they're like, let me test these links and then see what I can embed into this link to see if it'll actually work. And then now you go ahead and test it against all of these tools that are available, which is that responder tool and what that can be configured to do. And there's a lot of stuff. So when you put yourself inside of the mindset of an attacker, which is, I can understand why this is the first video inside of the exploitation module. This is the first room inside of the exploitation module for Cybersecurity 101, because they want to demonstrate this is what it's like, right? As recent as 2024. And you get yourself in the mind state of an attacker, and you're like, all you have to do is create this malicious link and have this thing on the back end, and then they're just going to connect to each other. And as soon as the person clicks on that link, you're just watching the display on your computer, and it's like, oh shoot, I just got their hash for their login credentials, and now I can use past the hash to log in as this person. And believe it or not, CEOs make silly mistakes like this because they're still human beings and they're susceptible to human error. And if you craft an email that's kind of intriguing, they will not hesitate to click on that link. So there are certain things that even CEOs are not exempt from, right? So this could work against upper management. It could work against the CEO, the CMO, people, especially if you start looking, like I love referring back to the example in Ocean's 11 where there's a security guard that they're trying to get the key card for the security guard. And as he's describing, he's like, yeah, he's this, plus he's lonely. And then the next scene is that they cut to the security guard inside of the strip club, and then they have paid the stripper to lean in, get all friendly with him, and then just pull his tag, his card, his key card from him, and then they pass the key card to Daniel, Ocean, and Rusty or whatever, and then they duplicate the key card, and then now they can do whatever the hell they want. It's that simple, right? It's like human beings are susceptible. Human beings can actually fall victim to all of these different emotions that we have, and it could be greed, it could be sloth, it could be lust. Lust is a really big one. That's why there's a honeypot. That's why there's so many campaigns of Asian or Chinese or Russian spies who are these gorgeous women who go after these politicians or whoever these guys are, that they're very humble looking, they're ugly for lack of a better word, and then they have this gorgeous woman approach them, and now they're at the whims of this gorgeous woman and they fall victim, and the gorgeous woman is actually a spy this entire time. There was a video that I did on sexpionage that you should go check out. So anyways, all of that to say that this is actually a very, very crazy thing, and it can happen to anybody, and you should always keep your guard up. You should always be paranoid. The paranoid survive. And especially in the world of cybersecurity and pen testing and hacking and all that stuff, which is the world that we're in. All right, we are officially done with this particular room. So if you found this video useful, I do encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out, especially inside of the CySec101 playlist, the Cybersecurity 101 playlist that we have. And then just go check out all these other videos that are available as well. This is the homepage, so you have all the playlists and everything that are connected here. But if you actually go to the videos tab, you will find all of the videos that we have, and there's a lot of videos that we have on this channel, and you are more likely to find something on the topics that have to do with cybersecurity. And then make sure that you drop a comment. I am responsive in the comment section. I check it from my phone all the time. So if you have a question, I'll respond to you. If you just want to say hi, I'll say hi to you. And if you have a really big question, then I'll go ahead and create a video in response to your question, or maybe even a playlist like we did with CySec101 in response to Darnell Knight's comment. And that's pretty much it. So like, subscribe, turn on the notification bell so that you get notified the next time that a video comes out. Drop a comment if you have any questions, or if you just want to say hi, or if you want to say thanks. And another way to say thanks would be to support this channel by joining the Hackaholics Anonymous membership community, which is the premier YouTube community for security professionals and hackers. And we have 4 tiers: the supporter, the agent, the guardian, and the master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click that join button, or you can go to youtube.com/@HankHacksHackers hackaholics.com/join, and you'll be able to join Hackaholics Anonymous. If you do, I really hope to see you inside of the Discord server so we can chat with each other. If not, I hope to see you in the comment section on the channel, and that's about it. This is your boy Hank Hackerson at Hank Hacks Hackers, your network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. Later.